Hello again. Welcome to ATAR exam preparation online video. Today we're going to explore a complex unfamiliar question. We use the vectors calculus to solve a question in relation to collision. So this sort of question is not easy, but we need to know how we use the vectors calculus to find the velocity and displacement, then also the collision point. So we got two particles, one or objects. So one is the displacement vector is given as VA for we call point A, VA, sorry, the RA. So I has a velocity called VA, but there's another particle is particle B or object B. So that velocity, the displacement didn't say. So we might call what we call, let's call RB. So we don't know, all right? But we know, the only thing we know is the velocity of the particle object B is square root. So that's the speed. The magnitude is speed, and the magnitude of velocity A. So those two together, so the relationship is multiplied by square root 2. We also got 2 points. One's a P, one's a Q. So object is released from, so let's see from P to Q. So object released from here, then towards the point of Q. So that's the 3-dimensional coordinates for P and the Q. So if we say those two objects going to collide, so we need to determine the time between the two objects, between a release of two objects. So what's the difference between the time? One, they collided, and from their collision, or from their release point to the collision point. What's the difference between the time? So let's have a look at the question. I've got two methods for this particular question. We solve method 1, method 2. Both is pretty long, so I'm going to pre-solved. So if go through quickly. All right, first I'm going to write the RT, RA, sorry, RA, we're using the original function, give that function, so we write into vertical form, column vector. So that's pretty simple. Then, so how do I find the RB? So we're using the position vector. So we know the if you look at the triangle here on this side, so we're using the triangles of P plus K. K is the parameter times by D, directional vector. So direction vector is basically the direction from P to Q. So it's a Q minus P. So when you take it away, P minus Q using the coordinates, so let's give those 3 coordinates. Then you put together into column vectors. Now at the collision point, those two displacement function or vectors should be equal. So we established 3 components will be equal. So we got 3 equations. 1, so that's the I component, J component, and then the K component. So the simultaneous equation. So that's a 3. All right, so let's do from So solve equation 3, we get k is half of t. So substitute to equation 2. So you got t. So when they collided, time taken for the displacement particle A or object A take 3 seconds. So that's the fly from so object B from release point to the collision point. It takes 3 seconds. So now we're going to work out what is the time taking the particle B, object B, from release point to the collision point. Then we're going to subtract them. So let's say this is a particle B. Start from P, then to the collision point. That's the collision point. So this is the collision point. So we call R. So the collision point, we can use the substitution because take 3 seconds from, so that position, we can use the RA to find that out. Substitute t equal to 3 into the function. So we got 6, 3, square root 3, 9, and 6. So therefore, we can find it. So how we work out a time from here. So this is a displacement from P to R. So displacement using the magnitude, which is the vector P to R, we're using magnitude of PR. So PR is using position vector R minus position vector P. So therefore, so R vector, we got the R is already given, so that's the R vector. So that's the R vector minus, so that's R vector minus P vector, which is given that. So subtract. So if you go back to P vector on the top, so that's my P vector, which is this guy. Sorry, this is the P vector. So we got P vector, then you take it away. So we subtract, then you take a 3 out. So we go to do the square root because of the magnitude of square root. So 9 square 3, then 9, so let's do 3. Square root of that is equal to 6 square root 2. So that's the displacement of particle B from release point to the collision point. So that's the how far it travels. Now we're going to use so we're going to find the time taken. So we need to find the velocity or speed. So we can use distance divided by speed equal to time. So how do we find the velocity? We know from the condition is a velocity of a B, magnitude of V, which is speed, equal to square root of speed of A. So let's find the velocity of A. We're using differentiation. So differentiate that. The magnitude is using the square root of A squared plus B squared plus C squared and equal to 5. So that's them. Therefore, the velocity of a B or speed, magnitude of velocity B is a square root 2 times by 5. So be 5 square root 2. So that's the speed. So time is a displacement divided by speed. So 6 square root 2 divided by 5 square root 2 is 6 over 5, so 1.2. So that's 1.2 seconds. So therefore, for the particle B from the release point to the collision point take 1.2 seconds. So take particle A take 3 seconds. So the time difference or time between the two particle release point is 3 take away 1.2. So it's 1.8 seconds. So that's the first method. So we're going to do method number 2. So this method 1, we're using the position vector and also use a vector equation. So now second methods, We're still using position vector for PQ, so we know PQ. So PQ using Q minus P, so that's the similar way we did before. I'll take a 2 as a common scale, take it out from the vector, from the vertical vector. Then I'm going to work out the unit vector for PQ. Why a unit vector? So we need to work out the PQ unit vector is PQ divided by, so this is the unit vector, magnitude. So this we call PQ vector, unit vector, we're using the little cap on the top. So this is the one I'm going to work out. So this is the key. Why we need a unit vector of PQ? Because my velocity of the particle B in that direction. So that same direction. So if I know the unit vector of the PQ, so we multiply the magnitude, so we can work out the velocity vector for the particle B. So I'll show you in a minute. So we're going to work out the magnitude, which is that. So then your answer will be square root 2 times by square root of 8. So it's a 4 square root 2. Then the unit vector of PQ. So that's the point of direction of, this is the direction. We need a direction of a PQ. So which is we talk about PQ direction. Very important. So that's the direction. So direction is unit vector. So we put that's the magnitude divided by times by 2 times by that. So the answer is, so 2 cancel. These are I'm missing some numbers here. Square root 3, 1, and 2. So therefore, the velocity of the particle B is equal to magnitude of the velocity particle B times by direction, unit vector of PQ, because they travel the same direction. So magnitude is 5 square root 2, because this is from the previous method, times by the so 1 over 2 square root 2 times by that. So the answer, those 2 cancel it out. So the answer is 5 over 2 times by square root 3, 1, 2. Then you can expand put it back to the Cartesian form. So now I'm going to find the RB, which is the displacement vector. I'm going to use integration. So we know the displacement is integration of the velocity. So take it 5 out to outside, so you can see. Sorry about some missing. All right, so we integrate that. So we get 5 over 2 square root 3t I component, then that's the j component, then that's k component. However, we need a plus c, so we don't know what a c is. Now, we know when the vector r particle b at position 0, time equal to 0, this is the point P. This is the position P, which is the initial point. So therefore, we substitute t equal to 0 into it, so the c will be that. So then you put it back into the r vector b, so will be equal to this format. So now, so we got RT, RB. So we got two equations. One is RA, one is RB. So if I let those 2 times, because their collision point, they collided, the time taken is different because the point particle A release time is different to particle B. So therefore, if I call T1 is the release point, time taken from the release point to the collision point. And T2 is the time taken for particle B to the collision point. So both has to be equal because the collision, when they collided, they should be equal. So therefore, I established the three simultaneous equations. So we solve from equation 3, we solve for T2 is 2 over 5 times by T1. Substitute equation 2 to find out T1 is 3 seconds. Then we need to find the T2 so that we can find the T1, T2. So T3 substitute equation number 3. So T2 is 1.2. Then the time difference is basically is T2 take away T1. So that's between the time difference. So it's a 1.8 seconds between the two objects. That's it. This is the long solutions for two different methods. Personally, I prefer the second method because it's just show you how to use integration to find the displacement from velocity. But don't forget to find the C. All right, that's the solution. Also, I wanted to let you know, so they collided, but at that time is because they release point is different. Release times are different. So that's why we call T1, T2. So we need to subtract them. T2 take away T1. Eventually, we need to take away the time. All right, thank you for watching, and don't forget subscribe to the channel if you want more videos. I'll see you next time. Bye.